Sometimes we want to find the volume of a hollow solid. Okay, what does it mean? It means that the there's nothing inside. Okay, there's nothing inside here. Okay, what you're going to do is to find the big one. Okay, for example, the big one is something like this. Okay, the big one is something like this. Okay, and then you're going to subtract the small one. The small one, for example, something like that. Yeah, print this one. It is something like that symmetry. Okay. Okay. So you're going to minus each minus. So for this one is integrate from a to b dx pi f1x all square. And for this one is integrate a to b pi f2x all square dx. Okay, then you take out the common factor pi and then the integral, and then you can subtract it before you do it separately. Both are the same. Okay, this one and this one are the same. And now we are going to see some more examples. Okay, this time these two curves. Okay, the area is this one. Rotate about x-axis. So you're going to find the big one from integrate from 0 to 1. The big one is pi y squared, that is ex all square, minus the small one. The small one is this one. Okay, pi x cubed all square. Okay, dx. The big one minus the small one, and then the big one minus the square one, and then you get this answer. And one more example, this one here, you're going to find a red curve, okay, and the green curve. Okay, this time this area is rotate about y-axis, not the x-axis. Okay, so I change another color. So it is this length. Okay, the green one. Okay, which is pi, this is x. Okay, x squared, and the height is dy. Okay, integrate from 0 to the intersection. Okay, the intersection is 9. Okay, and then minus. Okay, and then minus. Okay, this one x squared. For this curve, the green one, x squared is y. X squared here, you see that, sorry, the green one, the x squared is y, so this is y. Okay, and then for this one, the red one, the x squared is y squared over 27. So x, so the x squared is y squared over 27, and then all square. And then after some simple calculation, you find out that the answer is this one. Very simple. Okay, don't worry, you get many mistakes, but it's not difficult. Do it carefully. Okay, we'll look at this example. It's a little bit difficult. Okay, this is a circle, this is a circle, or this circle. Okay, and then you're going to rotate about y-axis. Do you know the shape? Of course, the shape is not very important, but if you know that, and then it is easier for you to find out the solution. Okay, yes, the shape is like a 水泡. Can you imagine? the superposed shape. Okay, so what you're going to do is to find out that this part, okay, I click green, okay, I click green, the green one, okay, you rotate about the y-axis, okay, this one rotate about the y-axis, okay, and then you get this shape. All right, it's this shape, okay, this shape I cannot draw very well, this shape, okay, and then you're going to subtract this shape, okay, subtract this one, okay. So here this is the x, and then for this one this is the x, okay. So I write it like this, okay. You are going to integrate, okay, pi, okay, I use the green one first, pi x squared minus the pi x squared, okay, but this one is of the length dy, from -1 to 1, okay. And then we focus what is the x squared. Here you see that x minus 2 all squared equals to 1 minus y squared, and then taking square root, you got 2 square roots plus or minus, and the green one correspond to x plus, okay, sorry, 2 plus root 1 minus y squared, and the red one correspond to x equals 2 minus root 1 minus y squared, okay. So be careful, okay. And now this is the red x, okay, all square, and then this is the green x all square, right? And then after some simplification you find out this one. I think most of you do not remember how to integrate this. You just getting rid of the square root. You have to let this, and then you will find out that this is integrable, okay. This is integrable, cosine square x, and then multiple angle, double angle, and then you get this answer, okay. You get this answer. Be careful, okay. The steps here is not important because it is only chapter 10, definite integrals. What is important is this part. You know that the area is the green x squared minus the red x squared, and then you get this formula, okay. The rest is what you learn. This part is volume of a solid of evolution about a line, not x-axis or y-axis, okay. For example, this line y equals x, y equals k. It is very simple. Again, it is pi r square, okay, pi r square. This is the r, okay, it is, and then this is dx, okay. So each one is pi r square dx, okay. You're going to integrate from a to b, okay. And now what is y? Pi, this is the corresponding y, but this y is a little bit different because this is y, okay, and this is also y. And now, but this is k, okay. So this r is fx minus k, okay. So integrate a b pi fx minus k all square dx. Do you understand? I repeat here. If I clean this part to make it simple, the height of this one is fx, okay, but the height of this one is k. So the height of this one, the yellow one, is fx minus k. Okay, then once you understand, then you will not be confused with what you learned previously. Now we look at some examples. This one, make sure that you understand, rotate about this line. Okay, so the area is here. Okay, this is the corresponding y, but you're not going to find out this one. Instead, you are going to cut these into strip. So this strip is 8 minus y. Length is 8 minus y. Okay, is it 8 minus y? Okay, so it is pi x y. This is y, but this here is 8 minus y all square. Okay, and then dx is dx, integrate from 0 to 2, 0 to 2, but you have to replace the y to x squared. Then you get this formula. Okay, once you get this formula, you can find out the answer. Okay, you cannot absorb all the stuff during this hour, so you have to read it on your own. Okay, I just outlined, and then you may refer to the YouTube if you don't understand. And then for this example, okay, rotate along this line. Okay, and then you want to cut into this. Okay, this one, you want to cut into this one strip. Okay, so each one is of dy. Okay, dy, and the y is just from here. Okay, you solve, put the 1 here, and then minus 2, and then put 1 here, 2, minus 2 to 2. Okay, and then the pi r square, the r square. Okay, the r should be 1 minus this one. Okay, 1 minus this one. This one is the corresponding x, so here is pi 1 minus x all square dy, integral minus 2 to 2. Okay, again the x, what is x, is y square minus 1 over 3. Okay, here minus 2 to 2 pi 1 minus y square minus 1 over 3 all square dy. You see that this term is the same as this term. You see that the order is different, but if the square, they are equal. Okay, so this integral is not difficult, and then you find that this ugly answer. Okay, try to